Alright, so for your Unit 2 test, for the alternating classes, the first 6 problems are going to be calculator and the remainder are going to be non-calculator in your practice test, so please make sure you pay attention to that as you do the problems. I suggest you do the problems solo and then check with the video. Okay, so in number 1, if P equals -5 and P prime is the reflection of point P over the line y equals 5, what are the coordinates of P prime? So you're going to start at P, -5, -4, and then you're going to graph the reflection line and do the reflection. So I like to use a graph. I'm going to go to -5, -4. There's my point. -5, -4. And my reflection line is y equals 5. That's a horizontal line. Okay, so if you had a big enough graph, you could easily count from -5 all the way up to the line. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so that is 9 away. So you would count 9 more from the line. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, notice that went off the graph a little, but it's still 9 units. So if you're trying to visualize this, the x-coordinate is not going to change because it just went straight up. And then your y started at -4, it went a total of 18 up, so -4 plus 18 is 14, so that point should be at 14. So we know this is 10, 11, 12, 13, 14. So P prime is -5, 14. -5, 14. Okay, next one, you're looking at the figure at the right with the reflection of A over the line PQ is B, and P and Q are on the reflection line. The measure of angle BQA is 37 degrees, and we want to know what is the measure of BQP. So we want this part of the 37-degree angle, so the whole thing is 37 degrees. And we want half of it because the reflection line is splitting things in half. So remember, you will have a calculator for this problem. So 37 divided by 2. The measure of angle BQP equals 18.5 degrees. And in question 1, I should say equals P prime. Okay. All right, question 3, a fan similar to the one shown below has 8 congruent blades. They are equally spaced. Blade M is rotated counterclockwise to the position of blade P. What's the measure of the angle of rotation? So you're starting at M and you're ending at P and you're going counterclockwise. So 1, 2, and 3. Okay, so your first step here is to start with 360 divided by the number of blades, which they tell us is 8. That's 45 degrees. And then we jumped, or had to turn 3 times, so we do 45 times 3, and 135. And since we went counterclockwise, our answer is positive, so our answer would be 135 degrees. Okay. All right, looking at number 4, triangle PQR is graphed. Point Q is rotated 90 degrees counterclockwise about the origin, then translated using the following rules. What are the coordinates of Q double prime? So the first thing you want to focus on is where Q is. Q's location is at 3, 0. So the first thing we need to do is apply the rotation of 90 degrees counterclockwise, and that rule is the opposite of y, and x. So to get to q prime, we would do the opposite of y, or the opposite of 0 is 0, and then the x would be in the back. Okay, so now we did the 90 degrees counterclockwise. Now we're going to apply the translation. So we're going to add 1 to the x and subtract 3 from the y, and that gets us to q double prime. So 1, 0 is where q double prime would be. So notice I was not concerned with p and r because the question was only talking about q. Okay. Next one, when a figure is reflected over the line with the equation y equals negative 5 over 2x minus 4, then reflected over the line y equals 5/2 x minus 1, what transformation occurs? Use mathematics to justify your answer. So this is two reflections. You want to be comparing the slopes of the lines. So we have a slope of negative 5 over 2, and we have a slope of 5 over 2. These are not the same slopes. So because the slopes are different, because the slopes are different, the lines will intersect, which will result in a rotation. Alright, number 6, we are doing a composite transformation. So we're applying the vector first to A, B, C, D. We want to know which quadrants will contain vertices of A prime, B prime, C prime, D prime. Notice it doesn't say double prime, which we're still going to have that middle figure, but our final figure will for some reason just be called A prime, B prime, C prime, D prime. So the first thing you do is the vector. So this vector's components are negative 3 because it's going left and it's going down, so every point is going to get shifted 3 over. Now we are going to go off the graph a little, but that's fine. We'll just have to visualize where it'll go. So negative 3, 1, 2, 3, 1, 2. So A prime is right around there, or I'll just call it A since we're going to follow our final figure A prime. B prime, 1, 2, 3, 1, 2. D, 1, 2, 3, 1, 2. And C, 1, 2, 3, down 2. So we applied the vector. Now we're going to apply the reflection over the x-axis, which, if you need to highlight it, is the horizontal axis. All right, so A prime is going to come 1, 2, 3, 1, 2, 3, probably right around here. D prime is going to be right around here because it was about 1 away. C prime is 1, 2, 3, 4, 1, 2, 3, 4. And B prime is on an axis, it's the y-axis. Alright, so which quadrants will contain vertices of that image? So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So we want to know where our purple points are. Doesn't look like there's any in quadrant 1, so there's some in 2, which you'll need to recognize written as a Roman numeral. There are some in 3. And since this point is on the axis, it's not in any quadrant, so it does not look like there's any in 1 or 4. But we want to know which ones contain the vertices. Alright, so that concludes non-calculator for if you're in the alternating geometry. So what will happen now is try to do these problems without a calculator. So in number 7, the size change to negative 10, 4 equals negative 4, 1.6, and centers at the origin. What is the value of k? K can be calculated by picking the x-coordinate of the image or the y-coordinate of the image and putting it over its corresponding point from the pre-image. So I am probably going to work with, remember this is your image, I'm probably going to work with negative 4 and negative 10 to avoid the decimal, because you do want to make sure it's simplified. So negative 4 over negative 10, the negatives definitely cancel, and this can be simplified to positive 2/5. Alright, next one, number 8, a rectangle with vertices 6, 10, 12, 10, 6, 18, and 12, 18 undergoes a size transformation of 1/2. What is the perimeter of the image? Okay, so the first thing I would do is I would probably graph this one since it's easier for me to visualize. So I would apply the size change to all these points, which means 1/2 gets multiplied by everything. So you're going to have 3, 5, 6, 5, 3, 9, and 6, 9. So and then I'm going to graph them over here. Get rid of this line. Okay, and it was 3, 5, 3, 5. It was, I believe, 3, 9. And then it was 6, 5 and 6, 9. So the perimeter of this figure would be all the rounding. So you could count all those boxes, or you could say it's a rectangle, so this side is 3, that side is 3, and this is 1, 2, 3, 4. So we have 4 and 4. Perimeter would be adding all those numbers up. So 3 plus 3 plus 4 plus 4. Remember, you probably would not have a calculator, so this is 6. And this is 8. 8 plus 6 is 14. And we could just say units. Alright, moving on to number 9. What are the coordinates of the image 3, 2 under the transformation 3x, comma, y minus 4? So all you need to do is substitute your values in. So x would be 3 times 3, because it's 3x. And then your y would be substitute your 12 minus 4 in. 3 times 3 is 9, 12 minus 4 is 8, and you want it written as a coordinate. Okay, number 10, what is the x-coordinate of the image? 1.45 is rotated 90 degrees clockwise about the origin, then translated 3 units to the left. So, 90 degrees clockwise, that rule is start at xy, and it's going to be y opposite of x. So if we did the rotation first, which it tells us to do that first, we get to 5, negative 4, and then it's going to be translated 3 units to the left, which means the x-coordinate, because x controls left to right, to the left means we subtract, so 5 minus 3 is 2, and it's only concerned with the x-coordinate. So we will be at 2. Alright, number 11, the points are equally spaced, and the lines are parallel, so we're going to have to do this composite reflection. So we're going to start at point Y, and we're going to take point Y over line B first. So 1, 2, 3, 1, 2, 3. So now we get to S, and we're going to be taking S over line A. 1, 2, and we're going to be getting to point U. So some people on your quiz had numbers for this type of answer, but you want to make sure it's asking for which point you'll be at, not how many jumps or reflections it was. Alright, number 12, you just want to look at this picture and make any conclusions about line M and segment TC. These tick marks are indicating that the segment is getting split in half. So all we know is that line M bisects segment TC. We don't know if it's perpendicular because we don't have that symbol there. All we know is it's bisecting the segment TC. Okay, 13, if points A, B are reflected over the x-axis, what are the coordinates of the image? So x-axis, x-coordinate stays the same, and the y-coordinate becomes the opposite. So we would be there. Okay, number 14, you're trying to see what would happen to each coordinate. It could be a rotation, it could be a reflection, it could be a translation, remember that's a vector, or it could be a size change. Okay, so looking at this one, we start at xy, we go to x opposite y. This would probably be a reflection because this is the rule for reflecting over the x-axis that we just used. Part B, we are adding 3 and subtracting 2 from the x and y coordinates, so that would be a translation because you're just adding and subtracting. Okay, the next one, you are multiplying each coordinate by something, so when you multiply by something, that's a size change. And the next one, you're multiplying the x and you're adding something to the y, so that's going to be a size change and a translation. So what the test might ask is, what properties are preserved if you did part A? So you would have to recognize that it's a reflection and then know what properties are preserved for reflections. They might ask you what is preserved in part C. You would have to recognize that it's a size change and then remember what properties are preserved during a size change. All right, moving to 15. This is an old part question from the geometry part. So ABC is defined in the coordinate plane. Here are our points. Which transformations will the image of the triangle be similar? So similar means it's going to be the same shape but a different size. So we want to be looking for all the ones that include a size change. And remember, a size change is when you're multiplying one of the coordinates by something. Okay? And it's something other than 1 or negative 1. So in A, it's nothing other than 1 or negative 1. Part B, because this 2y, that means that's going to be a size change. Part C, you can see the 0.5, that's going to be a size change. This is just going to be a translation because you're just adding or subtraction. And then E would definitely be a size change because you're multiplying by a number. So again, we are looking for figures that would be similar, which means same shape but different size. Okay, I'm actually not going to go through number 4 because we're going to do a practice BCR like it. However, you need to do number 4 on your own. So when I check your practice test, if you don't have number 4 done, you won't get that point. Okay, and now moving on to the BCRs. So this would be a calculator BCR, if you want to make that note. It deals with similar triangles, so I'm going to first graph triangle ABC. So 0, 0, B is at -2, 3, and C is at 4. 1, 2, 3, 1, 2, 4, 3. So we have A, B, and C, and then you want to connect with a straight edge. All right, and then you have triangle DEF. So D is at 2, 1, so 2, 1. E is at -2, 8. That's 3, 6, 8. B. And F is at 12, 8. 1, 2, 3. Okay, so that's F. And this was D. Alright, so the triangles are similar because DEF is the image. So I'm just going to go and put that on top. DEF is the image of ABC under a size transformation. Okay, and we are finding the center of dilation. So that means you have to connect all your corresponding points. So if you line them up like this, you can see that D corresponds to A. So I'm going to try to be as precise as possible using the computer. E to B. Okay. And F to C. Okay. So it looks like they are intersecting right here. And if I was 100% perfect, that point would have been at -2, -1. And now find the magnitude of the size transformation. So the magnitude is calculated as image over preimage. So if you set your triangles up already, you should see that DEF is going to go on top. So you want to make sure you pick the easiest distance to find is the horizontal or vertical one. And we have a horizontal E to F. So you could count those boxes, or you could see that it goes from -2 to 12. So that's actually going to be 14, or you could count them. Then you're going to put 14 over its corresponding length in the preimage. So E to F corresponds to B to C. So from B to C, you could count, or you could see that you're going from -2 to 4. So that's 6. And you're going to want to simplify that. So that's going to simplify to 7 over 3. So our K value is 7 over 3. Alright, number 2, this would be a non-calculator question, and I obviously do not have a mirror, but what you would do is you would reflect. So that first step would be to reflect ABC over line V, so over V, to get your primed image, so A prime, B prime, C prime. So this triangle would come somewhere over here. So then that second step is you're going to reflect your primed image, because you only want to reflect the preimage once, over U to get A double prime, B double prime, C double prime. So your final image will probably end up somewhere over here. Okay? And if the distance between U and V is 2.5, what is the distance from A to A double prime? So, to find A to A double prime, I know it doesn't say to justify, but you should, you multiply the distance, and you have to say between the parallel lines. Don't just say distance. So between the parallel lines, or between B and U, by 2. So remember, this would be a non-calculator, so hopefully you can see 2 times 2.5 is 5. So the distance from A to A double prime, which is also known as the magnitude, would be 5 centimeters. Okay, all right. You do not have to worry about number 3. You can cross that right off. And last but certainly not least, we're going to look at number 4. This was a quiz type question. So what I like to do is read through the question, and line J is this guy. And I also highlight the points that are on line J. Okay. And they told us that here. So if you couldn't figure it out from the picture, it tells you in the words. And then line N goes through the following. Okay? For what value of y is line N parallel to line J? So there are 2 ways you could do this. The first way is I'm going to use slopes. So I'm going to make a justification as saying parallel lines must have the same slope. So if these lines must be parallel, they must have the same slope. Okay, so I'm going to find the slope between of line J. So I'm going to be doing y2 minus y1. So 5 minus 8. 5 minus 8 over 3 minus negative 2. 5 minus 8 is negative 3, and 3 minus negative 2 is 5. So the slope of that line is negative 3 over 5. Now I'm going to find the slope of line N, and it has to be the same as that. So if I start here, I have to do y minus 2 over 3 minus negative 2. And what works out nicely is 3 minus negative 2 is 5, and we know that it has to have the same slope. So this number right here has to be negative 3. So then y minus 2 has to be negative 3, and you solve that one-step equation, y equals negative 1. That's one way to do it. The next way, so I'll label that as way 1, the next way is you could have said line J was translated or slid, was translated down to line N. Either way you choose to justify, you have to give one of these sentences in the work. So since line J was translated down, it started at 8 and got to 2. So going from 8 down something to get to 2, you realize that 8 minus 6 is 2. So we took 8 minus 6 to get to 2. So then this 5 also has to go down 6. So you would start at your 5, you would take out the 6, and that got you to negative 1, which is what that y value would be. All right, I believe that is all the questions on the practice test.